So what have you done? What have you done so far then? Have you done, do you understand what oil rig actually means?
Oxidation is loss of electrons and reduction is gain of electrons.
Okay. Do you know what else that can mean? Oxidation.
Gain of oxygen ions,
Yeah.
or just oxygen.
So yeah, so it's loss of electrons or it's gain of oxygen.
Yeah.
And then you've got reduction is gain of, reduction is gain of electrons. What about the oxygen this time?
Reduces reduction of oxygen.
Yeah, or removal.
Yeah.
Okay. So what examples have you done so far where you've looked at this in reactions?
We've done we've done as an example, in the half equation there's been, oh no, the full equation, Al plus Fe2O3 is Al2O3 plus Fe.
Okay. So do you know what the name of that reaction is? Have you got a name for it at all there? Have you called it the thermite reaction or?
Yeah, the thermite reaction.
Yeah. So this kind of reaction, this is one that's on railway tracks where if you're looking down bird's eye view, they've got little gaps in between the rails.
Yeah.
So the rail isn't continuous. So what they can do is they can do this reaction in like a huge bucket above it, and it produces molten iron. And then the iron just falls into the gap. They can cool it, shape it, and then you get a continuous rail eventually. So this is it's a commonly used reaction in the rail industry. There you go. There's a fact for you. So the aluminium, what's it actually doing then in this reaction? What's the job of the aluminium?
It's combining with oxygen or O3.
Yeah, so it's actually stealing that oxygen, yeah, to make a new compound and pushing out the iron, because actually out of all of these things here, the iron is what you want, and that will be liquid iron because it's a really exothermic reaction. This releases a lot of heat and enough to melt the iron. So why is aluminium able to do that to iron?
Because there isn't that strong a bond between iron and oxygen
compared to if it was aluminium and oxygen. So if you remember reactivity of metals, you haven't actually got aluminium in there in that list, but do you know where aluminium is? Is it towards the top or is it towards the bottom?
Would it be towards the top?
Yeah. So it's kind of just it's in here. Yeah. So it's more reactive than iron. And if you've got two metals that have got different reactivity, they can displace each other. Do you remember displacement?
Yeah.
So basically, is that coming back to you?
Yeah.
Where you get the more reactive, if you've got a more reactive metal, it can displace the less reactive metal from its compound. And then that forms a compound and leaves the less reactive metal on its own. Okay. So if you looked at what's going to be happening ionically here, because why is that bond? Why is that an ionic bond between iron and oxygen?
Because they're sharing electrons.
Are they sharing those ones?
The charge is neutral between them both.
It is neutral overall, but what kind of? That's a metal, and oxygen is a
gas.
So is it metal or non-metal?
Non-metal.
Yeah. And what type of bonding do you get between metals and non-metals?
Ionic.
Right. So what happens in an ionic bond that's different to covalent?
Is it?
So if we looked at iron, have you got your periodic table handy there?
Yep.
Just made a little mistake there. So we've got iron oxide. Okay. So if it's iron 2 oxide, what charge will it be on the iron?
2.
And what will it be? Charge 2
minus.
Metals. What are they? What ions do they always form? Metals.
Positive.
Why is that?
Because they don't have a full outer shell.
So how many will they have in the outer shell then?
7 or a low amount.
A low amount, yeah. So it would have 2 in the outer shell. So iron would have 2 electrons in the outer shell. And what will it want to do with those 2 electrons?
Share it with more iron.
Are you sure?
It will want to lose them.
There you go. Good. Right. So when it loses those 2 electrons, what will the overall charge be now on the iron?
2+.
There you go. You said it earlier and then you sort yourself out of it. So oxygen is in group what on your periodic table?
Yeah.
Which group is it in?
Group 6.
Okay. So what charge will that have then?
2-.
Right. But as you can see, you can get iron 2. This is iron 3 because, can you see the formula there? So that must be a 3+ charge because it's iron 3. That's oxygen 2-. So how many of these do we need in order to balance that?